Okay, so we are going to look at Chem Live question 13.14. We are going to figure out our data table, so what goes in the attic and what goes in the basement. And as always, what goes in the basement is going to be a whole number. So we have a read through, and in this instant, this is going to be the information for our basement. So this is going to be the NaOH, and our details are from our question are 25 centimeters cubed, 0.15 big M, and our ratio is 1. We're then looking for what goes in the attic, so in this case it must be the ethanoic acid. And our information from that is going to be 20.25. Our ratio is 1, and if we read down through, it says calculate the concentration of ethanoic acid. This must be our question mark. So we will be doing our first principles maths. So that will be, we will be using here as our way in. This tells us how many moles there are in a centimetre cubed. When we go down, we divide by 1,000 to find out what's in 1 centimetre cubed. When we go up, we're going to multiply by the titer volume of that. We're going to apply our ratio. That will tell us the moles at that particular titer volume. When we go down, we're going to divide by the titer volume, and that'll tell us how many moles in a centimetre cubed. And finally, to finish our maths, we multiply by 1,000 to find out what is in the moles in 1 centimetre cubed. We will also be using our mass triangle, using a molar mass that we'll calculate, and we also have the little percent weight per volume at the very, very end. So we've already said that up here, this 0.15 is our way in. And as you know, I always like to say what this means. So we have 0.15 moles in 1,000 centimetres cubed. We are going to divide that by 1,000. And when we do that, we are going to get 1.5 by 10 to the minus 4 moles in a centimetre cubed. Now, it doesn't matter how your calculator gives you your answer, you just write down whatever version it gives you. So mine is giving it to me in scientific notation. So we've now just done in our W divided by 1,000. From here, we're going to multiply by the titer volume, which is 25 centimetres cubed. When we do this, we get 3.75 moles by 10 to the minus 3 moles, and that is in 25 centimetres cubed, and this is our first titer volume. So we've now gone up to this part of our W. We then apply our ratio, which is 1:1, so it implies that there must be then 3.75 by 10 to the minus 3 moles, but this time it's going to be in the 20.25 centimetres cubed in that titer volume. So we've now applied our ratio, so we're over on this part of our W. We are going to have to find out what's in 1 centimetre cubed. So to do that, we divide 3.75 by 10 to the minus 3 divided by 20.25. And when we do that, we get 1.85 by 10 to the minus 4 moles, and that is in 1 centimetre cubed. So we've now gone to this point of our W, and then finally to finish off our first principles maths, we multiply by 1,000. And when we do that, we get 0.18518. So in terms of our significant figures, if in doubt, we go for 3 significant figures. Up here in our table, we technically have 4 significant figures, so I would always go 4 significant figures. So the 1 is my 4th significant figure. I need to have a look at what the 8 does to the 1, and that's going to make it go up 1. So 1.1852 big M would be our answer to this question. We all say we do our W and then we do our grams per litre. So to do our grams per litre, it is going to be moles by molar mass, which in this case is going to be 0.1852 big M, and it's going to be the molar mass of our ethanoic acid. And we have 12, 1 by 3, 12, 16, 16 and 1. And when we add all these up, we're going to get 60. So we're going to multiply our moles by 60. And again, to three significant figures, it's going to be 1.11 grams in a litre. So I wonder, when I was doing my data table, did you figure out the mistake I made? So I would always say we always look for all of the information in our data table. So if we look back to the question, we should have had an extra info line. So I apologise in my excitement. And our extra info says 50 centimetre cubed went to 250. So that gives us a dilution factor of 5. Okay, so that information is our dilution factor. We have a read of our question, which is here, and it is asking us to calculate the concentration of ethanoic acid in the original vinegar in moles per litre, grams per litre, and percent weight per volume. So if we have a look at the numbers that we've worked on, down here, this was our diluted vinegar. So to find out what's in original, I would multiply it by my dilution factor. So in this case, it is going to be 0.1852 multiplied by a dilution factor of 5. So when I do that, I end up with 0.926 big M. So this is going to be the answer to part A up here. So that's in my original vinegar. In terms of my concentration, down here, this is again in my diluted vinegar, so I need to multiply by my dilution factor. So I'll be multiplying that again by the dilution factor, which is 5. So 1.11 by 5 is equal to 55.55 grams in a litre. So we now have worked out part B, which is my concentration in my original. And the last thing that I have to do is work out for part C, percent weight per volume. Now that means grams per 100 centimetres cubed. So if I have 55.55 grams in a litre, to figure what that out is, I divide it by 1,000 to find out what's in 1, and I multiply it by 100 to find out what's in 100. And when I do that, I should get 5.55 grams per 100 centimetres cubed, which is the exact same as saying 5.555% weight per volume. And that then will bring me to the answer to my part C.